I'm Alex Wandel. I'm a researcher at the Technical University in Delft, the Netherlands, working at the chair of Environmental Technology and Design, and also the project leader of Horizon 2020 project REPAIR, which stands for Resource Management in Peri-Urban Areas, going beyond urban metabolism. And thank you, Teresa, for already introducing urban metabolism, so I can skip this one in this 10 minutes. So most of the things you see there are in-between results of a project that's running now 2.5 years and still has a duration of 4 years. Well, we have seen a lot today already that if we look at what where the extracted materials end up, then it's only 8% of it that is circled in any kind. Most of it is actually added material stock in cities, and if we look at where this materials, this virgin materials go in, then it's well, the images are according to percentage of amount. Then most goes in housing and infrastructure. Second most crucial is nutrition, and then we're talking about the mobility. So meaning when we talk, and this all is our cities, our regions. So I am from profession an urbanist, an urban planner and designer. So that is actually what we are daily working with. And if I put this then in opposition to two quotes from valued colleagues, then it becomes very interesting, because Joanna Williams here from UCL stated that the current state of art of the conceptualization of circular economy is inadequate when applied to cities. Namely, because on the one hand, it doesn't consider land very much, and it's very often not really related to context and space and location. On the other hand, colleague Michiel de Hane from University of Ghent says, well, water, energy, nutrient and soil cycles, as well as localization of food production, are rather new to urbanists. So we as urban planners, it's not something we are dealing with it daily. So this is kind of bringing these two worlds together is a tremendous challenge, and this is what we tried to do with the REPAIR project. And we are not doing this alone, of course. It's a Horizon project, so it's more than 18 partners in 7 countries, and we're working in 6 cities, specifically as pilot cities, Amsterdam and Naples. And as a follow-up cities, we have Ghent in Belgium, Hamburg in Germany, Łódź in Poland, and Pécs in Hungary. And if I want to put it in one line, what the project is it's connecting resource management with spatial development. This is in one line what the project is. Just a bit of background of the partners. In every city we have a university, we have a waste management company. We have also SMEs which are either in urban in consulting in urban development or planning, or in product development and so on. And we have also with us the Joint Research Center of the European Commission, which is specifically in charge for the sustainability assessment that we are developing with it. What is the outcome of it? The outcome is what we call a GDSE, a Geo-Design Decision Support Environment, and that is this kind of interactive tool. I have one leaning. I hope it's still leaning there. I have one leaning at the backside of the Amsterdam stand where you can test it. The idea is that we provide stakeholders in a region and we call it environment, so a touch-table interface that allows them to assess the quantities, the effects of different circular strategies in the region, what they mean, and we do that in a way that we do that in living labs. So we are the tool is not the means. Or it's not the end goal of the project, but it's actually the means to generate collaborative work in supporting the transition in these 6 cities. And it has 6. Is this the next slide? Yeah. And it has well, I can also the tool has 5 modules. The study area, status quo, target, strategy, and conclusions, which are always related with specific types of workshops. So, and it's a stepwise procedure from understanding what is actually there, what are the potentials for circular economy, what are actually the challenges, where do we want to get as a community, as a region, to then describing how is the situation according to these challenges, what are the targets that we want to formulate, what do we want to achieve, what are the strategies that we want to get, and then the conclusions is kind of a comparative sustainability assessment. That was, well, and we combine really simple post-it methods with computer methods. That was ways of how to define the key challenges and objectives in Amsterdam. What is also very important is that we apply a quite an holistic approach. So we for the status quo we did an integrated socio-spatial flow socio-spatial analysis, I would say, and flow analysis. And we started with investigating what is actually, because behavioral change is a crucial aspect in the transition. And then we investigated, okay, how environmental aware are people actually in the 6 countries that are involved in their handling of waste. And for us, and in the Netherlands, well, I like this chart very much because I'm Austrian living in the Netherlands, and this is kind of how the better up, the more aware people actually are dealing with their waste. And we were actually quite surprised to see the Netherlands rather on the bottom of the list, because it's a country where the institutional situation is already very upfront and advanced in the transition towards the circular economy. The companies are there, so the economy is there, the businesses are there, but we need to pay attention that we don't forget people on that way. Yeah? So, and that is, UK is not much better, by the way. So that is so. Land, well, I told you beforehand, land is something that is missing. So we said we also need to include actually what are the results, the wastescape, this wasted land, the results, the physical territorial results of the linear economy. And we mapped for the area, this just to orientate you, the city center of Amsterdam is here, and that's the peri-urban areas of Amsterdam. So we actually mapped what is the infrastructure that we need to use our sands. What are actually the waters that are polluted because of our linear economy? In this case, very much about the agriculture that is there. Which are the soils that are contaminated? Well, what are the industrial buffer zones that cannot be used for different or for in their complete value? What are safety and noise zones? The fact that Schiphol Airport is there in the center of this region actually makes quite some parts of the area less usable, and this is then in total gives us a map of wastescapes, which are also we see as a potential area. So if you want to shift to the more circular economy, then we need to harvest the full potential of these areas as well, and avoid producing new ones. So that was the side of land. And then it's about, of course, flows and stocks. And we saw now nice examples beforehand of material flow analysis, which always and mostly is presented in Sankey diagrams. And it always lacks a location. Who is actually producing where, when this flows? And what we did is we mapped what we call activity-based material flow analysis. So we used the location and the economic activities of different companies to map the flows on a spatial scale. We did this because it was in the Amsterdam metropolitan region selected from the, not decided from the stakeholders, that is construction demolition waste and food waste are the two most crucial waste flows to look at. So you see here now the map of the construction demolition waste. Here all the materials that we know on and from where it goes to. They are animated in reality, then you see a direction as well. And when you hover over it, then you see, okay, it's from this company, goes this much tons of that quality into this way of treatment and so on. Under the 290, the numbers is kind of clusters companies. It's if there are many companies in one location, then it's clustered. But we know it actually from company to company in the area. well, then you can actually investigate and look at this and see, okay, what is actually really already in the biospheric sphere, what is in the technospheric sphere, and we realize there's still a lot in the not so good sphere, and we are still burning much too much. Can do the same, well, for Naples, looks a bit different, but you see immediately how far these systems go. Yeah, we saw, of course, it's also about stocks. We need to understand what is in the materials, and we have the luck that we work together with Metabolics, and we have some of the material passports already in Amsterdam. So what we did, we used simple building typologies, building age, how they type of building, to actually get the landscape of the materials that are in the city. Yeah, so this is the brick map of the Amsterdam metropolitan region, and when we know which part is going to be redeveloped, we can have an idea. Okay, what is actually there in bricks, and we did this for 17 materials. I'm gonna skip over the food waste because it's all about building here now at the moment, and I have only 1 minute left. Important is it also allows to filter this database, so you can filter materials and so on, which allows, and that is the most important thing, to talk about eco-innovative solutions. I'll skip the theory, and I'll just show you two eco-innovative solutions. One is a very simplistic one, just to show the principle. Bread to beer. Every urban regeneration project nowadays has a microbrewery, right? And you can that's has to be. Don't know why, but okay. And there is a way that you can then you can actually use the bread that's not consumed in this process. So you can ask the question to the system: show me where is all the bread waste generated, and you get it, and where is it treated, and you see it's treated. It's produced in this. This is also one dot stands for one neighborhood, and it's treated as far away as in Germany. Parts of the bread that is wasted in the Amsterdam metropolitan area. So I would prefer to have a microbrewery somewhere here. But that was a simplistic, very simplistic example. Much more complicated, and I'll switch with you. This is a snapshot of the energy labels of the buildings in the city of Amsterdam, which is deep in the red. So which means if we even want to come close to achieve our climate and energy goals, we need a lot of insulation material in the next years. And if we put these insulation materials that we are having now, then we are relying on mineral and oil-based insulation materials predominantly, and we're actually putting the waste of the future in our buildings that we cannot reuse as well. So in this co-design thinking, what would it mean actually if we produce renewable insulation material based on reed and mycelium? There are several examples of the fantastic use of mycelium that this works, so we can actually make the city the regenerative city and use biomaterial. We did then, you can make an analysis, okay, where can you actually grow the reed, where can you produce it, where can you actually combine it with effects so that it also cleans the polluted waters that I showed you beforehand and so on, and relate it with where buildings are gonna be redeveloped and so on, and come to a solution that is much more in the city. Show how the systems are related with each other. We do so also because we saw that urbanists and architects are not yet ready there, so we do really situated learning. So we have courses running where we educate our urbanism students, and we are lucky we have every year around 100 really handpicked students that we can deal with. And actually we succeed also in influencing already the public discussion in the Netherlands. And because if we're talking about the circular city or regenerative city, which I would even prefer, then we also need to talk about how the city looks like, how the landscape looks like, because otherwise, and I come back, we're not gonna get the people with us. Thank you very much.